I'd now like to hand over to Merrily Needham, who is going to chair this meeting. Professor Needham is the current Foundation Chair in Neurology, a joint position between Fiona Stanley Hospital, Murdoch University and Notre Dame University, Australia. She was the head of neurology unit at Fiona Stanley Hospital from 2015 to 2019 and is the current head of neuromuscular and myositis research at the Perrin Institute, Western Australia. Thank you very much, Merrily.
Thank you very much. Now you know a little bit about me, but I actually do have a very small sense of humour, and I'm sure that Drew didn't realise I had the right of reply immediately after him. I think a very important word that he did leave out is when I said there's no cure for motor neuron disease. I meant to say that or I might have said, there's no cure yet for motor neuron disease. And I hope that what we get from the symposium today is hope. And you'll see how hard people are working towards changing the future with motor neuron disease. And it's in fact very fitting that our very first speaker, Professor Matthew Kiernan, is speaking on the topic, Hope is on the Horizon, Advances in Research. For those of you who don't know Professor Matthew Kiernan, he is one of the giants of neurology in Australia and in fact the world. He is the current Bushell Chair of Neurology at the University of Sydney in the Faculty of Medicine. He is also the President of the Australian and New Zealand Association of Neurologists and a Director at the Discovery and Translation Centre at the Brain and Mind Centre in Sydney. Matthew is also the Chair of the Pan-Asia Consortia for the Treatment of ALS, or sometimes known as PACTILS, and it is my great pleasure to introduce him to you all this afternoon.
Well, thanks, Merrily, and it's a very hard act to follow, Drew Bathgate, but I'm glad that we're in the presence of his classic greatness and his Rolls-Royce approach, and I think that's a good message to bring forward. I'd like to thank Perth for hosting the International Symposium, and it's really great that there's so many patients and families and carers at today's meeting. It's really only through patient advocacy that many of the things that we're going to talk about has really reached fruition, and it's a very strong partnership with patients, their families, clinicians and researchers, and I think that's really been brought together through this international symposium. We have a lot of involvement of patients, plus the basic scientists trying to educate the clinicians and the clinicians trying to at least provide entertainment for the basic scientists. So I think that there's been, massive awareness now in motor neuron disease, and that was really triggered off by the Ice Bucket Challenge. Certainly in Australia, there was $20 million of donation. In the United States, 140 million. In the UK, 40 million. In, Netherlands, Canada. And that really has spurred research into motor neuron disease, and everyone now knows about motor neuron disease, so the community awareness has been great. And it's been taken on by another level through MND Australia and MND Research Institute of Australia, and also through events like the Freeze at the G with Neil Danaher. And basically, one day at the MCG, seeing people walking around with MND hats, generating 1.2 million just from selling beanies, generating $6 million of support for MND research in Australia is really powerful. And it brings a lot of people into the discussions, including Greg Hunt and politicians in general, state ministers. And that's really where we can try and push things further. And this is walking from Federation Square to the MCG, everyone wearing MND beanies. And you wouldn't have imagined this, 5 or 10 years ago. So the whole landscape has transformed. So Australia actually has a long tradition in MND research, and it goes back to A.W. Campbell, and he was an Australian working with Sherrington in the late 1800s, early 1900s. And his critical part was to actually suggest that MND was a disease of the brain. And that's been a very controversial area. Most people have got into motor neuron disease through neuromuscular medicine, but more and more, particularly through some of the more recent discoveries, we've realised that MND is a primary neurodegenerative condition, and it very much has its onset and origins in the brain. The other thing is, so more than 100 years ago in the Medical Journal of Australia, here was a case report detailing motor neuron disease, and I think it gives a very classic history. So typically he had never experienced a day's illness. It's a bit like the dog we heard who's chasing the cars. He's very fitness orientated, Then developed right-hand weakness in the muscles between the thumb and the index finger. And again, that's a very typical beginning for motor neuron disease. And why is that? Well, I think this is really reflecting the evolution of humans. We're the only mammals who have a pincer grip. So this has been very important in terms of like moving slides along, holding credit cards, using knives and forks, etc. But that is a massive design flaw in the human brain. It's got a huge amount of energy needed, and that's often the other area that we've evolved, obviously, is communication, despite Drew's dog. The fact that we can speak and interact with each other, again, is an evolutionary area, and I don't think this is pure chance that these are the areas that are usually selectively affected in motor neuron disease. And this presentation we can work out now from 100 years ago is what's called the split hand of ALS. It's like there's been a split down here, and the reason for that is these areas here have got massive representation in the parietal cortex, so this is an upper motor neuron presentation. So that's a brain presentation of motor neuron disease. Then they describe very similar changes on the left-hand side. So typically, if you have involvement of your dominant right-hand side, it'll move very quickly to the same muscles of the left-hand side. And that's presumably through transsynaptic movement across the corpus callosum, which is the part that joins the two hemispheres together. So we have a part of the brain that stops us, simpler mammals, when they do one task with an arm or a leg, the other side does exactly the same, because there's free communication from both sides. But human evolution has triggered off this process, and ultimately the diagnosis is ALS. So I think similar to the past sort of giants of neuroscience, we've been very keen in Australia to have involvement with the global approaches, and we'll hear of many of those approaches during the week, but the two speakers here this afternoon have driven many of those, and including Project Mind, trying to get all of the genetics for sporadic ALS patients, 12 or 13,000 individuals. And it's only through these powers of large international consortia that we can have any chance of trying to work out this condition. If it was a simple condition, one gene leading to one disorder, it would have been solved a long time ago. But it's a very complicated multi-hit process. And we've been very grateful for the support from MND Australia and Carol Burks with Project Mind. And already, by being part of these international consortia, we're seeing that, you know, new understandings of the genetic architecture are coming out, and also the links across brain and mind diseases. So patients who have motor neuron disease have higher incidence in the extended family of people with autism, bipolar disorder, schizophrenia, Parkinson's disease. So this is really part of a sort of a global brain and mind series of conditions. And what we've tried to do in Australia, as well as contributing to the international consortia, is develop our own national pathways, and very much with Merrily here in Perth and our colleagues in South Australia, Queensland. So we're trying to now generate, it's called a partnership. So we have an app that is patient-driven, so the patients have all of their information, seeing the various clinicians that are involved and allied healthcare, etc., but at the same time driving the research and availability into clinical trials, providing samples to our Australian consortia, which is driven by Naomi Ray in Queensland. And we're starting to see now very much a more sort of general involvement and a more focused approach that is already leading to better results. But in terms of treatment, I suppose the biggest sort of step forward from when Charcot had described the disease occurred in sort of the late 80s and 90s, understanding the genetics of motor neuron disease. And the first mutation that was identified was superoxide dismutase. And in fact, a number of Australian families contributed to those findings, particularly through Garth Nicholson and Nigel working here in Perth. But really, I suppose it was a bit of a surprise because no one actually knew what SOD1 did. And they went back to basic biochemistry and tried to understand how mutation in that gene would lead to the process of motor neuron disease. And that led to people looking at it's part of a redox reaction, excitotoxicity. Glutamate is involved, and in fact, colleagues in the north of the UK, so Pam Shaw, who'll be at this meeting, and Jeff Rothstein in America, started measuring cerebrospinal fluid in patients and found that glutamate was upregulated, and that led to this idea of excitotoxicity, that something triggers off the motor neuron and it starts firing, releasing glutamate, and glutamate is toxic, and that leads to the cascade of cell death. And I suppose very soon after that, riluzole was identified and went through clinical trials, driven particularly through Vincent Meninger from Salpêtrière. And that was a way of trying to reduce glutamate, or so it was thought. And these studies were published in The Lancet and New England Journal. Australia was involved in those clinical trials, and we were a clinical site for the introduction subsequently of riluzole. But it was a simple idea that maybe riluzole reduced glutamate. But really, I suppose what we're starting to see is maybe riluzole is slightly more complicated. And rather than getting into too much sort of research, but if you stimulate the motor neuron with a magnetic stimulator, patients with motor neuron disease have a hyperexcitable cortex. And that probably leads to symptoms like cramp, fasciculation, and so on. And when you start patients on riluzole, you start to see that the hyperexcitability is reduced, so inhibition is increased. It doesn't actually get back to normal, but it starts to approach normal and then gradually winds down. It's also become clear that riluzole works through persistent sodium conductances at a neuromuscular junction. And that led to a whole restaging of what riluzole may do, and that was undertaken by Amar, who's the next speaker, working through his King's database, showing that riluzole has positive effects in motor neuron disease patients at all stages of the disease, including the last stage, the end stage of the disease. And probably that suggests that it may be working through different pathways to maintain function. So that's something that we need to consider further. In terms of therapies, really it's directed by being part of a centre that has an interest in motor neuron disease, and ideally multidisciplinary care. So this is our team in Sydney, which has a nurse coordinator, representatives of the association, occupational therapist, speech pathologist, physiotherapist, social worker, and it's through a sort of a combined team that outcomes are better for patients with motor neuron disease. And this was a study published by Orla Hardiman, who will also be attending the meeting, looking at her clinic in Dublin, and showing just by attending a multidisciplinary clinic, your survival was increased by 300 to 400 days relative to attending a single neurologist. So that's an important message. And then if you add riluzole to multidisciplinary care, the outcomes are much better. Separately, we're understanding now the role of non-invasive ventilation, so putting patients on ventilatory support, particularly overnight. And this was a study, a trial undertaken by Pam Shaw and her colleagues in the north of England, and they showed that non-invasive ventilation improves survival, also improves quality of life. So patients feel better, they have more energy, less headaches, and more active. I suppose what we need to do now is work out when do we institute non-invasive ventilation. As it stands, we start the therapies usually when patients are symptomatic or when their respiratory function is deteriorating. The other thing to say is we've actually got a lot of therapies for motor neuron disease to cover the symptoms, so muscle cramps, spasticity, overproduction of saliva, breathlessness we've covered. We're understanding now the critical role of weight loss and nutrition, and also emotional ability. And what we've tried to do on a national platform, and this was published in the Medical Journal of Australia, is get all of the clinics together to try and have a national approach to therapies. Merrily mentioned Pactals, and that's been an exciting development. So although we appreciate our colleagues in Europe, they are really probably the dying force. And the strength of the region is going to be in China, India, with $1 billion each. So Leonard has come down to a mission and he wants to take over. But we've always said, look, we're going to stand it alone and see what we can do. But actually, it turns out there's great strength in Korea, Japan, and we're trying to set up now a trials consortia to drive these approaches together and also to better understand the genetic differences. And we've had our first standalone meeting in Korea, and our next meeting next year will be in Japan. We've also taken on some of the concepts that have been developed by Amar and Leonard, looking at motor neuron disease as a multi-hit hypothesis. So we've now been able to look at it in terms of Australia, but also now with 5,000 Japanese patients, 3,000 Korean patients, and shown that motor neuron disease is a linear relationship, suggesting that there are 6 hits that have to occur for motor neuron disease to develop. 3 of those hits, if you come with a family history of motor neuron disease, that would account for 3 of them. And then what are the other 3? Well, we're not really sure, and they could be random. But this is where we really need to get together in larger consortia. There are some interesting studies coming out now as well for new treatments, and one of the areas that is taking off is the whole role of inflammation in neurodegeneration. And this was a release from AB Science in France, for their medication tyrosine kinase inhibitor masitinib. This works through trying to reduce inflammation and microglial activation. And there's going to be a larger scale trial undertaken in which Australia will be involved hopefully next year. Now, while riluzole was approved in Australia after the trials in the mid to late 90s, the second medication to get FDA approval has been edaravone, which is owned by Mitsubishi Pharma. Again, works through free radical scavenging. And at the moment, patients who want to access that have to go either to Japan or work out some import license to get it back here to Australia. Although I think that there's going to be some announcements shortly that there will be a company in Australia that will be releasing it, so edaravone should be made available to patients around Australia. Courtesy of our National Clinical Trials platform, we've been able to now take on investigator-driven studies as well. And this was a study that was supported through the Medical Research Futures Fund. It was a $4.5 million donation so that we could look at Tecfidera, which is a therapy registered for multiple sclerosis, trying to alter the populations of neuroinflammatory regulatory T cells. They weren't attacking the motor neuron, so they may slow down the process. And we recruited 120 patients around Australia with sites here in Perth, Brisbane, Adelaide, Melbourne, and we're just about to lock the data down and see what those results show. At this meeting later this week, we'll hear from Cytokinetics, who are going to explain the results of their Fortitude study. There's a lot of interest, obviously, in genetic therapies, cell therapies. So the SOD1 ASO, anti-nucleotide sensing oligonucleotide study, has commenced in Australia with Westmead Hospital and Steve Vucic as the national lead. We'll be doing C9 studies next year. There's also a press release today for the results of Neurone, so a stem cell approach that was driven particularly through Massachusetts General Hospital, showing that there may be some benefit in a phase 2 study for those who have very fast progressing disease. Ryuji Kaji from Japan will be here at the meeting. He'll be presenting his findings on methylcobalamin. He's now started a phase 3 study to get FDA approval and Japanese approval for high-dose methylcobalamin. So this is a process that is moving forward. Another inflammatory approach has been driven through Australia. So Julian Gold did the Lighthouse study. So that was a sort of a proof of concept and a safety study looking at Trimec, which is a medication for HIV therapy, and showed that firstly it was safe, it didn't affect riluzole, and had some suggestive movements in the right direction in terms of biomarkers. And now we need to do a larger phase 3 study, which will hopefully be a collaborative approach through Europe and Australia. I suppose in terms of not trying to have excuses, but it's taken us a while to actually understand, and we haven't fully understood the biology and the pathophysiology of the disease. And without understanding the disease, we still inevitably have to have sort of shots in the dark and try and do approaches without necessarily having the full biology. The other thing that we're working out is that not all ALS or MND is the same. So there's a lot of heterogeneity in patients. And there's also a lot of differences in how people respond to the disease. Some people may live for 10 to 15 years. Some people are dead within a few weeks. So there's a massive range, and we don't have good ways to try and identify that. Although by trying to get to the genotype and then the resultant phenotype, we may get some better understanding. We've also realised that all clinical trials from now on should have a biomarker component, so that if the study is negative, at least we're going to learn more about the biology of the disease itself. And I suppose, we've also been involved in tricky areas as well. So dexpramipexole was a study that showed benefit at a phase 2 study. So Biogen invested $40 million to do a large-scale international trial with Australia as one of the sites, 990 patients. And then we got to the end of the trial to find out that it was negative. And that's sort of a really flattening experience. And part of that is, again, not knowing the biology, but also trying to interpret phase 2 early phase data. So the other thing that we're getting a better understanding of is that there are, pre-morbid personality types and physiques, and there does seem to be a higher incidence in people who are very physically active. And this was really brought out firstly by Adriano Chio, looking at the football players in Italy. We can see and Lou Gehrig himself, but on the right-hand corner up there you can see the Australian Davis Cup squad, so Brad Druitt, who looked after had bulbar onset motor neurone disease. The person beside him, Peter Doohan, who recently died of motor neurone disease. So 2 players in the one team getting motor neurone disease. We've got Just van der Westhuizen, the captain of the South African football team, Neil Danaher. So there seems to be a suggestion that there are different types of protoplasms linked to motor neurone disease, and this is a very typical history. You know, this is a patient from Northern Territory, and the background is there's no medical background. So these patients don't present with any past medical history. They've got no medical notes. Whereas when you see someone, for instance, who has a stroke, they might have multiple admissions with diabetes, poorly controlled blood pressure, heart disease, etc. And going back through this, generally motor neurone disease patients, they have a low or normal body mass index. They're rarely obese. They're usually fitness-orientated, athletic, and studies from both the UK and also Leonard's group have shown reduced coronary artery disease in patients and their relatives. And some people think that there is also a personality type with motor neurone disease. So certainly we find our patients are very, they say hello to us, which is probably more than our own colleagues do in the department. So there's something different. So we've started looking at our patients and going back with their carers and asking them, you know, did they notice any changes? And in fact, 3 or 4 years before they developed motor presentations, their carers had noticed that there'd been, you know, changes in their personality, sometimes more impulsive, more sort of prone to temper outbursts, some people more sort of apathy. So there'd been some cognitive changes that had presented well before the motor presentations. And similarly, there seems to be metabolic changes. So oftentimes patients will lose dramatic weight loss, 20 to 30 kilos, before they've had any bulbar weakness. So there's some sort of metabolic process linked to the degeneration. And these are studies that we've been taking forward in Sydney, but also colleagues in Brisbane, and looking at insulin resistance, lipid profiles, and eating behaviour. And it's very interesting, when patients who have a normal or low BMI start to increase their BMI, that's often the indication that they are developing cognitive problems and potentially frontotemporal dysfunction. So I think the other area that we're very interested in is we see patients typically at this region here, and it's very hard from once you diagnose them over, say, a 12 to 18 month period to really find major changes. But we don't really know what has gone on during the course of their adult life, going all the way back actually to conception, in utero, delivery, the maternal environment. And this is, I think, where there's going to be a lot of important discoveries going into the next few years. We also don't know when the process of neurodegeneration is triggered off and how that is progressing, because we don't really have a marker of these changes in the brain. And so the other thing to say is that we do know that there seems to be a focal onset, and should we be trying to direct our therapies very early on at that centre in the brain? And I think with the advent of nanotechnology, drug delivery systems, I think we're going to start seeing some better outcomes for our patients. And so on that note, I would say that I think there is hope on the horizon. I think the whole landscape of motor neurone disease is changing. We've been very fortunate to have great community involvement, patient advocacy, great generation, basically great donations and philanthropy, and that is really driving now. We've got industry, philanthropy, government ears, and I think that we're getting a much better understanding of the biology of motor neurone disease, and I think the outcomes are already better, and that was established through Stan Appel, who's been running a clinic since the 1960s in America, and he's shown that the outcomes now are much better than the patients for 1960. So of course we wanted even greater acceleration and improvement, but I would say that a lot of these things are well underway, and I'll leave it at that. Thank you.